All right, today we're going to talk about sets of numbers. Sets of numbers are really important because they explain the difference between different number groups, and they also help us to explain what our answers are. We'll use them further on down the road, and we'll use them as explanations and also as limitations to what our answer sets can be. So it's really important that you understand the different sets of numbers and what numbers fall into each category. I will make comparisons between the sets of numbers and a family to help clarify what the different sets are and how they relate to each other, okay? So what I'm gonna do is I'm gonna start with the smallest set of numbers, which is natural numbers. Natural numbers, as the names indicates, it's like what you could see in nature. And the see part is the really important thing. So with natural numbers, it's what you could see in nature. How many people can you see? Well, you can't see no one because there's nothing there to see. So natural numbers, they have to be 1 or larger, okay? So the technical definition is non-decimal or fractions 1 or larger, okay? But what I'm gonna say is what you can see. So it's gonna be 1, 2, 3, blah, blah, blah. And it's gonna continue on like that, okay? The next largest group, or next smallest group of numbers is whole numbers. Whole numbers, you guys have used this term for a long time, but you were using it incorrectly because you were taught incorrectly. Whole numbers are what you can own, okay? The technical definition is non-decimal or fraction, 0 or larger. So the only difference between whole numbers and natural numbers as a set is that whole numbers includes all natural numbers and also the number 0, okay? So whole numbers, I say it's what you can own. You could own 0 cars. You could own 50 billion cars. You couldn't own a car and a half. You can't have part of a car. So it's either a car or it's not a car. If you got a headlight, that's not a car, sorry. So you can't own a fraction of a car. So whole numbers, what you can own. A lot of times I'll say this is how many siblings you can have. You can have no siblings, you're an only child. You can have 50 billion siblings, but then people always tell me, well, no, I got a half brother. Okay, well, too bad for you. Okay, so this one's gonna be 0, 1, 2, 3, blah, 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 and it keeps going forever, okay? The next smallest group is integers. Integers is what you were taught were whole numbers, non-decimals or fractions. Now, just because it starts as a fraction, it doesn't mean it actually is a fraction. So if I have like 10 over 2, that is a fraction, but it can be turned into a whole number, which also would make it an integer at that point. So integers, non-decimal or fractions in simplest form. So for this one, I'm gonna go dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. So it continues on negatively and positively. It goes on. Integers is a much larger group than whole numbers and much larger than natural numbers as well. Okay? Now, with just these three, these ones we will use a lot. I'm gonna give you the symbols to represent them. Natural numbers is easy, it's N. That's the symbol to represent natural numbers, okay? Whole numbers is easy, it's W. That's the symbol to represent whole numbers. Integers, it's a little bit harder, Z, to represent integers. And we're gonna keep on going. Bigger group than integers is rational numbers. The technical term for rational numbers or technical definition is can be represented as a fraction. Any number that can be represented as a fraction. Now, why do I use the word represented? Because it doesn't have to be a fraction right now, but it can be represented as a fraction. So what does that mean? 0.3 repeating forever, we say, is 1/3. So that can be represented as a fraction. 7 can be represented as a fraction, 7/1. So anything that can be represented as a fraction is a rational number. I'm not going to give more examples. It's going to be any integer or any decimal that repeats itself or any decimal that terminates. So if I have 0.123, that can be represented as a fraction, 123/1000. Okay? So terminating decimals, repeating decimals, or integers, all of those can be represented as a fraction, so they're rational numbers. The largest group is real numbers. As of right now, real numbers are all the numbers you know. Later on, we'll get into a more technical definition of that. Right now, I just want you to think of it as all the numbers you know. Every number you know belongs to the set of real numbers, okay? And so we have one more group besides rational that we're going to use. So we have rational and then a separate set. And I did real first because real goes bigger than rational. It also goes bigger than our other group, but our other group's not included inside of it. So we have rational and irrational. So rational numbers can be represented as a fraction. Irrational numbers cannot be represented as a fraction. So this is usually radicals, like the square root of 7 is irrational, or non-terminating decimals that are also non-repeating. 0.12379642173, blah blah blah. It goes on forever, so you can't turn it into a fraction. It goes on forever and it doesn't repeat itself. That's an irrational number. Okay. So rational numbers we represent with a cube. Real numbers we represent with an R that is just a little bit funny. I put 2 legs on it. This is like the most common one that we're going to use, and we want to write it like that. Okay, we need to distinguish it from just being an R, and we need to show what we're doing. Okay, so that's what we're looking at here. Okay, we got all these different groups, and now I'm going to talk about the other part that I was saying I was going to talk about, which is a comparison between your family and the number sets. All right, and this video is getting really long, so I'm going to try to do it quickly. Natural numbers are you. Whole numbers are your immediate family. Your mom, your dad, your brother, your sister, whoever lives in your house. You belong to this other group. Oh, well, I should put family over here. And whole numbers over here. You belong to the group of your family. But not everyone in your family is you. So you're inside of that circle. Just like natural numbers, all natural numbers are also whole numbers. But not all whole numbers are natural numbers, because whole numbers include the number 0. Okay? And then a bigger group is our integers, which is your extended family. So this includes people that do not live in your house. It does include the people that live in your house, but it also includes the people that don't live in your house. Grandma, grandpa, cousin, Frank, whoever. So they're part of your family, but they're not part of your immediate family. They don't live in your house. Integers, everyone that lives in your house is part of your big family. But not everyone that's your big family lives in your house. So that's kind of what we got going on here. So all whole numbers are also integers, but not all integers are whole numbers. All whole numbers belong to this set. Not everything in this set belongs here because we have negative values here as well. Rational numbers are like Texans. And for the purpose of this, we're going to assume that everyone in your family is a Texan. Okay, so everyone in your family is a Texan, but not every Texan is in your family. Every integer is a rational number, but not every rational number is an integer. We have stuff that can be represented as a fraction, and we have stuff that can't be represented as a we have stuff that can be represented as a fraction that's not an integer, like 1/2. But we also have stuff like 3 in this group, okay? The bigger group than that is real, all the numbers we know, and inside of real, we also have irrational. Irrational. So it's like we have Texans, US citizens, and then inside this big US citizens, we also have prisoners. Yeah, they're US citizens, but they don't have all the same rights as everyone else. And that's the irrational over here, okay? Sorry that this video is so long. I apologize. I'll probably cut it into 2 parts.